All right, thank you everyone for joining. My name is Chris Nunn. I'm the Head of Sustainability at AMP Capital Real Estate, and I'm also the Chairperson of the Australian Passive House Association. And this is our first attempt at a webinar, so I hope you are able to hear me okay and see the content as I flick through it. This is a repeat of a presentation I delivered at the Property Congress, which is the largest property conference held throughout the year in Australia. It was held in October last year up in Cairns, and I presented this to a largely a room of commercial property developers, basically. So the focus here is on explaining Passive House to a non-technical audience and showcasing some of the world's best Passive House buildings which have been built in a commercial context. So we can begin now. So I'd like to start, and forgive me for those of you who are Passive House experts, but to cater to the lowest common denominator, I think it's worth starting with the name Passive House. Passive House, the word, don't be fooled by the name. In German, the end of Passive House means building, not just a house. So a rat house is a council building, which I find quite amusing. A Krankenhaus is a hospital building. So house is not designating just residential. It can also apply to commercial buildings. So the next slide is a cartoon which I really like, that I think demonstrates the evolution in design thinking that with Passive House as the culmination. On the left, the one titled 19th century. Historically, we used to build buildings that were simple but uncomfortable and energy intensive. Then in the middle, the 20th century, we figured out how to make buildings comfortable, but they were complicated and energy intensive. And that's arguably where we are now with most of our current commercial building construction. On the right, the 21st century is the Passive House buildings, which represents arguably a future state for commercial buildings, but is the present state for Passive House. These buildings are comfortable, energy efficient, as well as being much simpler. The building fabric does the work of keeping the building comfortable. So you don't need a lot of expensive and energy intensive heating or air conditioning, and they don't leak. So you don't need a lot of fan power to ventilate the building with fresh air. There are 5 key principles of Passive House: continuous insulation, airtight construction, minimizing thermal bridges, having high performance glazing, and using a mechanical ventilation with heat recovery system to provide fresh air. So I'm not going to go into the technical details of Passive House because that's a subject for another day, perhaps. This is more an introduction to some of the benefits of Passive House and the examples of Passive House commercial buildings around the world. So just touching on some of the advantages, Passive House buildings are healthy. They have a constant fresh air supply with no recirculation. So there's no buildup of VOCs, there's no buildup of particulates, there's no buildup of CO2, carbon dioxide. And the attention to air tightness and thermal bridging means there's no drafts, there's no condensation, and there's no mold. And there's less risk of airborne allergens due to the air being filtered by the mechanical ventilation with heat recovery system. So Passive House buildings are better for people's respiratory health. Passive House buildings are also comfortable. They don't overheat and they don't get cold. It's a fact that more people die from the cold in Australia than they do in Sweden annually. And that's a result of the way we build our buildings in Australia, particularly our residential buildings are not built to the same standard that our European counterparts are building buildings. No one's going to die from cold in a Passive House building because they're well insulated, they're well sealed, and they stay warm in winter. And that is an issue in Australia. You might say that's not an issue in Australia, but we do have cold temperatures. Anything below 16 really starts to get uncomfortable, and we have temperatures dropping well below that. And that's a result, and we see the results of that with that statistic around more people dying in Australia than they do in Sweden, notwithstanding the huge temperature differences. Passive House buildings, as you'd no doubt be aware, are also very energy efficient. Passive House buildings are dramatically more energy efficient than conventional buildings, using up to 90% 90% less energy to cool and heat than a conventional building. High quality. Passive house buildings are high quality. They're well sealed so they don't leak conditioned air, and the insulation and high performance glazing mean they have great acoustic properties, so they're good for shutting out external noise like traffic, aeroplanes, or train noise. They're also resilient. A passive house will function in a heat wave, and they're resilient to the predicted impacts of climate change. We know the predicted impacts of climate change include that we'll have hotter summer temperatures and more heat waves. Passive house buildings are much more able to resist these conditions and will continue to perform while other buildings overheat. So they'll stay habitable much longer in a power failure. If there's a blackout or power failure, a passive house building will continue to be habitable for longer than conventional buildings. So there's a business continuity benefit to passive house buildings as well. And passive house works for all building types. It works in all geographies and all climates. There are passive house high-rise office buildings, fire stations, schools, hospitals, apartment towers, aged care facilities, social housing, and tens of thousands of individual dwellings. The Passive House Planning Package software tool that underpins the Passive House standard is sensitive to the climate zone of every project. It prompts the designer to adjust the amount of insulation and the type and extent of glazing and the amount of shading required depending on the local climate. So Passive House is an adaptable building design and construction system that is adaptable and can be therefore tailored to any climate zone around the world. And it's got a long history, a long track record. It's been running for 26 years. It started in 1991 when the first passive houses were built in Darmstadt in Germany. So it's got a long and successful track record, and the implementation of the Passive House standard is still overseen by the International Passive House Institute in Darmstadt in Germany, with local chapters in most countries around the world, including Australia and New Zealand. And it's widely used. There are over 80,000 certified passive house buildings around the world, and that makes it the most widely used sustainable design and construction system in the world. This is a map of passive house certified buildings, and it doesn't show all 80,000. It shows about 4,500 certified passive house projects that have elected to be listed voluntarily in the International Directory of Passive House Projects. And you can look that up, and there's key details for all to see. And you can see that, you know, based on the passive house projects that are voluntarily listed on this website, it is primarily a European phenomenon. It started in Germany and spread throughout Europe. It's really big in the UK, where I worked for 6 years, and it's gaining a lot of traction in the US and Canada, particularly in those cold northeastern climates of the US. So there's a lot of passive house certified buildings in colder, heating dominated climates like Germany, Sweden, Japan, Korea, Boston, Seattle, and New York. But the point I want to make here is that it's also being applied in hot climates, such as California. There's passive house buildings in Mexico, in Portugal, in southern Spain, in Malta, in Sicily, in Turkey, in Athens in Greece, in Dubai in the UAE, and in Guangzhou in China, all of which have hot and in some cases very humid climates as well. So passive house is a standard which works both in warm climates as well as cold climates. Now on to the case studies. This is a photo of the first high-rise office building built to the passive house standard. It's a 21-story, 27,000 meters squared, modern commercial office building. It's in Austria, and it was built by the Raiffeisen Holding Company as its headquarters building. Now, the Raiffeisen Holding Company is a commercial bank. It's one of the largest financial institutions in Austria, and it has a diverse range of holdings from real estate through equities, debt, infrastructure, etc. So it's a bit like an AMP Capital where I work, with its headquarters building being this certified passive house office tower. Now, the Raiffeisen Holding Company has an environmental institute, a charitable foundation, And I think one of the reasons why they chose to build a passive house as their headquarters was the influence of this environmental institute on the thinking of the CEO of the company, the Raiffeisen Holding Company. So this building is called the RHW2, which is RHW is the Raiffeisen Holding Company of Vienna, WIEN in German. So the Raiffeisen Holding Company 2 building. They also own a building adjacent to it, which is their former headquarters building. So hence RHW2. This building was built in 2012. So it's actually already had a pretty significant 5-year track record of commercial operation. So it's tenanted by the company that built it, and they're still there. And it's a modern commercial office building. You can see from this lovely image of the central atrium of the Raiffeisen Holding Company building, RHW2 in Vienna, that it wouldn't be out of place as a premium commercial building in Melbourne or Sydney, where we have the headquarters of major banks like the National Australia Bank or Commonwealth Bank or Westpac. This would suit their headquarters style very similarly. I think this building is actually, this atrium is quite reminiscent of some of the internal spaces, for instance, at 700 Burke Street, where we'll be holding our conference later in the year. If you come to the conference, you can check that building out. It too has a central atrium to provide connectivity between floors, and as does the Commonwealth Bank headquarters in Sydney at Darling Quarter. So it's quite a, I think, consistent format with banking headquarters that we've seen around the world and are familiar with in Australia, and yet it's a certified passive house building. It's got a beautiful central daylit atrium. It's got a kindergarten and a catering kitchen. It's got 250 car parking spaces. It's what we'd think of here as a normal high-performance commercial office building. It's got a double skin facade, which is one of the high-performance features of the building. It's also got great views, as you can see on the top right, which is one of the upper story views from the corner. It's adjacent to the Danube River and across the river from the historic centre of Vienna. And those great views aren't compromised because it's a passive house. While it does have a spandrel panel, you can see the views are preserved. It's not impeded by the high-performance facade in the way that some might expect a passive house facade to be. So I think that's a really successful example of a commercial office tower that's achieved passive house. The next case study I wanted to talk about is The House, which is a residential student accommodation building built by Cornell University on Roosevelt Island in New York. So this is immediately adjacent to Manhattan. You can see in the image in the center at the bottom its position relative to downtown Manhattan. And it's currently the tallest passive house building in the world. It was completed just last year, so it's quite new. It was 26 stories, and it's a 352-unit student accommodation facility with room for about 530 students. And you can see in this image that's just popped up, it used a modular prefabricated facade panel system. So its speed of construction was high, and the quality of the facade and the airtightness and sealing were very high, and it enabled it to be built in a short space of time while preserving those really high quality envelope characteristics, which are key attributes of a passive house building. So I think that's a great example of an institution like a university investing in the comfort, health, well-being of its students, and also a long-term asset that it will continue to hold and run over many years as an owner-operator. Those low operating costs that they'll see from the 90% lower energy savings mean that they'll continue to benefit from those low operating costs for the life of that building. The next example is a master planned passive house district in Barnstadt in Heidelberg in Germany. It's a 112 hectare passive house district for about 12,000 people. It's also a science and biotechnology innovation hub. So it has office buildings, research laboratories, university teaching facilities, as well as thousands of residential dwellings. And they are all certified to the passive house standard. You can see the scale of the development up on the top right, and you can see one of the facades, really nice, interesting facade system on one of the university teaching buildings, which is also certified to Passive House. This is the Bolueta building in Bilbao in Spain, which was due to be completed towards the end of 2017, so it's likely to have been completed now. It's a 28-story, 88-meter high residential tower with 108 units, 63 of which will be social housing rental units. So this is another great typology of Passive House being used for a vulnerable population. Like you can imagine the Cornell University students don't want to pay too much for their accommodation. They're already stretched financially for the high fees of going to Cornell University. So those low operating costs are helping them. And likewise, in the social housing context, you've got a vulnerable population who may be on a fixed income and they don't want to be exposed to the price shocks of energy increases. So this 90% lower operating costs, which are typical of a Passive House building, is great for a vulnerable population, both in protecting their thermal comfort so they don't get exposed to cold or extremes of temperature like heat waves, but also for protecting their financial security in that these should be affordable to run and to occupy. Now, Bilbao in Spain has a climate that's a bit like Melbourne, actually. It reaches more than 30 degrees in summer and it gets down to about 3 degrees in winter. So it's got a big thermal range, but in summer, it's a very warm climate. So, you know, this, by analogy, you could think of this as not out of place in a cooler climate like Melbourne in Australia. This is a picture of twin residential towers in Vancouver, which received planning approval in 2017. The address is 1400 Alberni Street in Vancouver, and it's due to be completed in 2022. It's located in the west end of downtown Vancouver, and these are New York Art Deco style apartments, which I think is a really nice facade solution to not having too much glazed area. To do it in an Art Deco style, I think is really in keeping with the sort of North American tradition of high-rise residential, and also means that you don't have too much solar glazing. So the developer is the Lander Global Property Groups out of China, and there's a strong connection to Vancouver, particularly via Hong Kong, with a lot of Hong Kong emigres residing in Vancouver. So these towers are 43 and 48 stories in height, and they'll have 450 units, 129 of which will be rental apartments. So it's a build to rent apartment block, which in the commercial property sector in Australia is a really hot topic. The build to rent investment market in North America is actually the largest asset class. The largest asset class that institutional investors own is residential apartments. So they don't necessarily strata them off and sell them. They hold the building long-term, manage it centrally with central services, and then they lease the buildings out as, you know, either service apartments or just rental apartments where people bring their own furniture conventionally like we would. But it's a really big asset class in North America, and it's an asset class that's set to grow. And if it does, we might see more Passive House residential in Australia, because an institutional investor who's going to own a building long-term, like Lander Property Group will own this building, these two buildings long-term, has an interest in those low operating costs to attract tenants on the, you know, sales pitch that this will be cheap for you to occupy, but also in that it's a building typology that is built to last. It will have a long, productive economic life and deliver stable returns to the investor. So they might be prepared to invest a little bit more upfront for a higher quality solution like Passive House. I think one of the other drivers for Lander Property Groups in building these two huge towers in Vancouver is that Vancouver has an aspiration to be zero carbon by 2030. So they've got very strict planning requirements in Vancouver, meaning that all buildings have to meet a very high standard of environmental performance. And so it's only natural that you will start to see more Passive House buildings coming up in Vancouver. So it's also got a daycare center. And so I think this is a great example of a high quality, really large scale residential project, all built to Passive House. and outside of Europe, I think importantly. And Vancouver's got a fairly mild climate that's a bit like London, if you can imagine that. You know, fairly cold, but not freezing winters, typically a little bit of snow potentially once or twice a year, and then quite warm summers, you know, getting into the 30s. This next example is a residential building in Changxing in China. It's called Bruk, B-R-U-K, which means bridge in German. And it's metaphorically a bridge because it was done in partnership between Chinese developers and the Passive House Institute in Germany, who contributed a large amount of research knowledge to the optimization of this building for what is quite a warm, humid climate. It's similar to Brisbane. So it gets down to a minimum of 15 in winter, so it doesn't ever get very cold, and it gets up to over 30 degrees in summer. So it's a tropical, humid climate in Changxing. So this is a great example of a passive house building working in a building where humidity is a challenge and where heat and the cooling loads in the building are the primary design driver. It's a 5-story building with 2,200 meters squared of floor area and 46 residential units. It was built in 2014 by the Landsea Development Group in China, and this won the gold medal for World Green Design Award in 2015. This building's been studied by the Passive House Institute in Germany and has been shown since it's been built in 2014 through to now, it's been shown to have a 95% energy saving relative to similar residential buildings built to normal building codes in Changxing. So in a hot, humid, cooling-led climate, this building has delivered 95% energy savings, which is just really remarkable in my opinion. It's also got a really interesting external shading facade system. So the colorful rods you can see are terracotta rods that shade the facade. So it provides extra solar shading, and you can see the sort of deep reveals around the window that provide both horizontal and vertical shading from the sun. So I think it's a really good looking building that's, I think, quite contemporary and consistent with, you know, how we build residential buildings facades in Australia. Like, I don't think that would look out of place. Is really suitable for aged care for the reasons I mentioned earlier around social health, social housing. It provides stable, comfortable temperatures, which is really good. And it's got so retired people on a fixed income, suitable. Sorry, 1 second. Sorry, I think I dropped out there. Can you see again? Sorry, I think we had a technical problem. I hope you can see that screen sharing now. Apologies if that dropped out. Can you see the screen again? I'm just waiting for confirmation. Naomi's texting me. Apologies for the technical issue there. I hope it's sharing again. I'll just continue while I'm waiting for confirmation to come through about that, because I understand you can still hear the audio. So the next example I had was a nursing home in Austria, which is 118 units. It's really suitable for aged care. This is so retired people on fixed income with low can benefit from these stable, low energy costs. We're nearly at the end now, so apologies that we've lost the screen. I can see that you can still hear me okay, but and I'm sorry, just fiddling around with a few settings here to try and make sure you can see the screen. It is saying for me that it's sharing my screen with Google Hangouts. So I'm just reopening that. There's a hospital in Frankfurt, which is the next example I wanted to refer to, and we're nearly at the end now, so I might just press on without the images. The hospital in Frankfurt is due to be completed in 2019. It has 10 operating theatres, 666 beds are planned. There are 6 stories. It's about a 78,000 square metre hospital facility with 2,000 employees. So it's a really significant hospital building, and it will serve about 80,000 patients each year. It's a 240 million euro development in the state of Hesse in Germany, near Frankfurt. And so Hesse currently incurs around 3,350 euros per hospital bed, and that is expected to drop by about 80%. So the provincial government objective they have an objective of becoming climate neutral by 2050. And that's something that we are seeing more and more, is that local governments are setting these climate neutral or zero carbon targets by anywhere between 2030, 2040 or 2050. And we're seeing Passive House as a really strong response to that. I think I've just shared the screen again. I hope that's something you can see now. Really strong response to that planning driver of carbon neutral. Passive House is obviously a great way to get there. With a little bit of solar on top or a little bit of renewable energy procurement, you can get a zero carbon building. So the final example I wanted to talk to is a police building in Hesse in Germany. The provincial administration, as I said, has an aim to become carbon neutral. And this 4,000 square metre building, which is an administration building for their police department, a government building, which will be nearly zero carbon effectively. So a great example of government leading the way with a public body committing to a world-leading standard like Passive House in one of their key administration buildings. So just wrapping up now, Passive House is a performance-based design and construction method developed by German building physicists. So it's the best you can get. It delivers great performance outcomes in terms of quality, efficiency, and resilience to climate change. It does cost more, but there are estimates that in commercial buildings, the cost premium for Passive House is only 3 to 9% more. So it's not a significant additional capital cost to achieve those high performance outcomes in terms of comfort and lower operating costs. And to date, there are about 11 certified Passive House buildings in Australia with a pipeline of 71 registered. And if you do achieve Passive House in Australia, you're eligible for 30 Green Star points. So for me, as a sustainability professional, these are the buildings that are fit for the future. Passive houses are comfortable and they're low energy, and they certainly inspire me, and I hope they inspire you too. And that's the end of the presentation. Thank you very much for listening, and I really appreciate your patience as I work through those technical